Welcome once again to another fascinating math video. This time around, we shall be considering solving problem from a transformation geometry. Before we go over to the solution of the problem on the board, I'd like to inform you that I offer a private online math tutoring service, both for the primary level, secondary level, and even college level. So if you need of this service, be very free to get across to me because I'm a qualified tutor when it comes to this regard. I have a practical teaching experience which spans over a decade. All right, so be very free to get across to me if you're in need of this service. Now, it will interest you to know that there are different types of transformation. In the elementary level, we have the transformation geometry and other types of transformation. We also have the Laplace transforms, Laplace transformation, the Fourier transformation. There are so many. But we want to consider the geometrical transform, all right? Now, over here, it says that the vertices of triangle ABC are represented by the vertices minus 2, 1, B, 2, 0, C, 2, minus 2. These are the coordinates of the vertices of this triangle ABC. Now, we are required to show that the area of triangle ABC is preserved under a reflection in the line y equals to x. Practically speaking, a reflection is the image you see when you look in a mirror. It's called look in. That is the point of emphasis, not look at, not look on, because the image is in the mirror. All right, so there's a distance between the object shape and the image shape. So now we are required to reflect the entire shape ABC in a line y equals to x. This line now denotes the mirror line or the line of symmetry between the object shape and the mirror shape. All right? So first of all, we need to know the effect a reflection will have on a coordinate. Now, if we are given a coordinate s, y, all right? And these coordinates have a corresponding vector written as a column vector, sy, all right? If we are given a coordinate in this form, under a reflection in this line, the coordinates will become yx in this manner, all right? So under a reflection in this line, this will be the new coordinates. So that means that if we are to reflect this, there will be an interchange of position. That is the meaning, all right? So with this knowledge, we'll be able to solve this problem. Now, we are to show that a reflection preserves the area of a triangle, that a reflection does not have an effect. Now, a reflection is an example of what is called congruency. Congruency is a transformation that leaves the shape of the structure of a shape invariant. It will not alter anything in it, all right? So, thank you very much. So, let's look at the effects a reflection will have by this I've explained, all right? So, under the reflection, M in the line y equals to x. So M here stands for the reflection, right? See that? Let me remove this from here to avoid confusion. So under a reflection M in this line, these coordinates, the coordinates A, let's start with this. A, we map onto the image A prime of minus 1, minus 2. There will be an interchange of positions, as I said earlier, all right? Okay, likewise, similarly, this point B, we map onto its image. We call it B prime, and that will be 0, 2. The last point C, which is 2 minus 2, we map onto minus 2 C prime, minus 2 and 2. So these will be the images of this point, of this pre-images, all right? So we want to show that the area of the triangle ABC is preserved. That is, the area of ABC is equal to the area of A prime, B prime, C prime. So we have to show, let's indicate that by writing. We have to show, so we show rather that area of triangle ABC is equal to area of triangle A prime, B prime, C prime. Very logical, all right? So that this area is preserved. Now, how do we get the area of triangle ABC? Very easy to do. Now, we'll make use of this formula, which says that the area of a triangle, let's suppose Okay, without any further ado, I don't want to make things too lengthy. Let me just go straight to the point. Let's calculate the area of ABC, all right? So area of a triangle ABC is equal to writing the modulus, or half the modulus rather, of the determinant. So what you do, you put 1, 1, 1. If you know how this formula, if you want to know how this formula come about, you can make your comments, and I shall provide you a video that show how we got the formula, right? But for the y, it suffices to apply the formula to solving this problem. Now, let's take note of, we are dealing with ABC. Now, in ABC, the x coordinates are -2, 2, and 2. So we align them accordingly, all right? So we have -2, we have 2, then we have 2. Can you see that? Now, the y coordinates are -2, 0, and -2. So we have -1, 0, and -2. So this is the area of this triangle. So what we do, we evaluate this determinant. So in doing so, we have it as half modulus of, now how do we evaluate this? We take the cofactor of 1 added to this other second one, added to this one you see here, all right? So the cofactor of this will be 1 multiplied by what? You block this column and also block this row. So what you'll be left with, 2, 0, 2, -2, all right? Then minus the cofactor of this other one is -1 multiplied by, so the same thing, let me remove this out, it will be clear enough. I'll take away this now. So what you do, you block this column here this time around and also omit this row. So what we are left with, -2, -1, 2, and -2, all right? Then the cofactor of this is +1. You block this time around, I'll take away this to avoid any confusion. All right, I'll take away this also. So we block this and this. So we're left with, this time we're left with -2, -1, 2, 0. So there is the area. So what we do, evaluate this. So we have this as half multiplied. Now 2 times -2 will give me -4, right? We have -4. Then 2 times 0 will give me 0, -4 minus 0. So we have this. Then now 2 times -2 will give me -4. Okay, let me put this one here first. -4. -2 times -2 will give me 4 rather. Then -2 times 2, -1 times 2 will give me -2. We have this. Then plus -2 times this, we have 0, all right? 0 -2. Modulus. So we're good to go. This now we have it as half, here will be -4, all right? This is 6, because minus is plus, so this is 6. Then with this minus here, we have -6, -6, yes. Then here we have +2. So everything here will give us half of the modulus of, now -4 minus 6 is -10, +2 will give me -8. Now, the modulus of a negative number is a positive number. So when 2 divides into it, you have 4 square units. 4 square units. So that is the area of triangle ABC. Now, we have to show that the reflection preserves the area of the triangle. So we have to calculate the area of this, our image, triangle A prime, B prime, C prime, and compare with this result, whether it's the same thing. If they are the same, we've been able to show that the reflection in the line y equals to s preserved the areas of the triangles, all right? So let's go back to doing that. I will erase this part from the board now. If you've not done a copy of it, please quickly do so that you can go through it later. All right, so I give it time to snap or do anything. I want to wipe it off. All right, let's suppose you've done that. So I'll remove this from the board. So next, area of triangle A prime, B prime, C prime. And that is equal to writing half of the modulus of the determinants. Once again, you write 1, 1, 1 to be the elements in the first row of the determinant, all right? Now, this time around, what we have here, we've erased the coordinates. Don't forget, I can easily explain from here. Don't forget the image of A is -1, -1, -2. Let me write this somewhere to avoid confusion. Look at this, A prime is -1, -2. Remember, We did this earlier on. Okay, now the image of B prime is 0, 2, right? And out of this, we have this as minus 2, 2. You see that? This is a recap. Now, what we do, we enter the data again accordingly. So we have minus 1 this time around, 0, and minus 2 for the S coordinates. All right, that is this line you are seeing here should be entered in this region. Then also the Y coordinates should be minus 2, 2, and 2. Can you see that? So we have this at hand. So what we do, we evaluate the determinant. So I will remove this out of the board to do the evaluation. So this is equals to writing half of the modulus of what you do, you write 1 again. Now if you block this column and this row, you'll be left with 0, 2, minus 2, 2. Right? So we have 0, 2, minus 2, 2. That will be the cofactor of 1. Then the cofactor of this 1 here is minus 1. Now to get the entries, we block this column and this row on which it lies. So when we do that, we have minus 1, minus 2, minus 2, 2. So we have minus 1, minus 2, minus 2, 2. All right? And lastly, the cofactor of this one, we have 1 multiplied by the determinant. We block this last column and this row on which this entry exists. So if we do that, we'll be left with minus 1, minus 2, 0, 2. See that? Then all into modulus. Then this is equals to writing half. Now we shall expand this. When we expand it, 0 times this will give me 0, minus 2 times minus 2 will give me minus 4. So we have 0 minus minus 4. All right? For this determinant you see here. We'll go over to this. We have minus 1 multiply. Now minus 1 times minus 2 will give me minus 2. Minus 2 times minus 2 will give me 4. All right? Can you see that? Then plus 1. The same thing applies. Minus 1 times minus 2 will give me minus 2. Then 0. Can you see that? So we're almost done with the problem. Let me take away this on the board. Then this is equals to writing half modulus of everything here will be 4. The minus 2 minus 4 will give me minus 6 times minus 1 will give me plus 6, right? Then here will be minus 2. Then here we have half. Now 4 plus 6 is 10 minus 2 8s. And modulus of a positive number will be positive. Then 2 divided into this, we get 4 square units. All right? So you see that it's the same thing with the area we calculated for triangle ABC. So that shows that indeed a reflection preserves the area. So we've come to the end of this particular video. Be very free to get across to me if you need of a private online mentoring service. And do me the favor to like, share, and make your comments about the video. Thank you very much. I do really appreciate you all.